I am Ryan Boland, your moderator, and we are so glad you could join us. Today we are here to learn about conditioning data for advanced energy management strategies. This webinar will teach you about conditioning data for energy efficiency projects and initiatives, energy accounting for utilities including fuel, steam, and water, applying advanced thermodynamic calculations, and carrying out combined mass and energy balances. Now I am happy to introduce Elena Mola, a Sigmafine specialist with PIMSoft.
Thank you, Ryan, for the introduction to the presentation. Key topics that we want to cover with this presentation are how to use Sigmafine in energy domain in many different contexts. We all heard about Sigmafine only applied to production, accounting, and material balance, but this is not the only one application. Then we will see how to monitor the equipment performance and calculate reliable KPIs. And then we will see how Sigmafine can support the compliance to the standard for the energy efficiency. We all know that the energy cost fluctuation of last years have affected the company strategies. If energy monitoring and management was not considered a priority in running a plant a few years ago, now controlling energy use is on everyone's mind. For this reason, all companies should have a trustable method to measure and validate their energy usage. Also because the companies need to provide verified and auditable data to the training partners, to operate within environmental limits, and to profit maximization based on the energy balance. In general, the goal of every smart business is to get the best result at the lowest cost. In this sense, Sigmafine represents a solution that can be applied to different contexts, to LNG through all the chain, from production to regasification, to the utility network, the power generation, and to monitor the energy-intensive processes and equipment. We will see some examples during this presentation. We can distinguish two different levels where Sigmafine is applied. First of all, at the level of energy accounting, providing a set of consistent data for the reconciled energy productions and consumption of the plant. This can be mainly applied to the utility network, for example. Then another level is the energy performance monitoring to provide equipment performance and KPI based on validated data. In this way, Sigmafine can act like a unique repository of the process knowledge for both the accounting and the engineering purposes, depending on the level of detail that you are focusing on. So if you are focusing on the plant level or the equipment level. Sigmafine provides several instruments to use in the energy domain. First of all, we have the Sigmafine analysis, the plugins. The way how Sigmafine works is that it acquires raw data from the plant, the historicized measurements, the design data of your equipment, tank or valve datasheets, and then applies the reconciliation analysis to a model in a case context, daily case, hourly, monthly case, and then provide a set of reconciled data. Sigmafine, in terms of energy balance, can handle two types of balance, the linear LNG balance or the iterative analysis that solves both the mass and the energy balance so that you will have a final set of consistent data for both the mass and the energy in the same time of each flow that you have in your model. In addition to the analysis, we have the extensions. So this is a set of Sigmafine calculation that can be applied in the energy domain, such as the thermodynamic, the steam tables, or the LNG and LPG calculations that are typically focused for this product. And finally, there is also the scheduler to automatically execute the analysis and the full Sigmafine workflow. Let's move now to a series of examples of Sigmafine applications. Let's consider a fuel gas network. We create a Sigmafine model that includes all the fuel gas sources, for example, the natural gas from outside, the fuel gas produced by the plant, the process units. Then we include in the model also all the consumers, all the process units, the flare and the boilers, etc., and all the nodes that represent the collectors of your network. Then we can run the energy balance of the network to get a consistent set of energy productions and consumption of all your plant. So Sigmafine permits the users to acquire knowledge of current situation and detect imbalances of the network. The heating value of the different sources is calculated by Sigmafine according to the flow meter data and the analyzers. And then after the reconciliation, it's also possible to calculate reliable emissions based on reconciled data. So in this way, we can ensure higher accuracy of the emissions respect the emissions calculated on the raw data. If we consider a steam network, then we can execute an integrated mass and energy balance on it. You can even build a very complex model that represents the entire network of your plant. This picture was taken from a model that was very complex and had 4 different levels of pressure. This model, you see, represents all the components that are included in your steam network, such as the turbines, the heat exchangers, the collector, the letdown stations. And since we want to run integrated mass and energy balance on this network, we need mass measurement and the energy measurement. The energy measurement is calculated by Sigmafine thanks to the Sigmafine steam table. So according to the level of pressure and temperature of the steam, Sigmafine estimates the enthalpy. And regarding the mass content, if you don't have the direct measurement, then Sigmafine can calculate the mass quantity of the flow according to the opening of the valve and the characteristics of the valve. This is an example of how Sigmafine is applied to LNG industry. When producing and selling LNG, an accurate estimation of the energy content is very important. Here the model represents a purification separation train. The gas is coming from 2 different pipelines, and a simultaneous mass and component balance is applied on this model. Each pipeline has the raw data of the mass and the composition coming from the plant or laboratory data, and the Sigmafine solves the simultaneous mass and component balance around the model. In addition to the energy and component balance, there is the LNG extension that is configured to improve specific calculation for the LNG, such as the compressibility factor that is used to estimate the vapor phase content in a biphase tanks, which is a parameter very important for LNG industry. Like many other commodities, also the power industry is experiencing lower emission limits and rising regulatory requirements. This forces the companies to remove any efficiency in order to maintain competitive prices. Since the power industry interface with the public, Sigmafine can satisfy the need to validate and reconcile data based on business rules and international standards to be aligned with the auditing controls. Then in power generation industry, there is a huge amount of data with high frequency, even hourly frequency. Also, data consistency is not solved by itself. So Sigmafine can represent a unique system where the data are consistent one each other in terms of also of different unit of measure. Finally, Sigmafine can accurately monitor the production and environmental strategies. For example, supporting the product distribution optimization, deciding to produce heat instead of power, etc. The second part of this presentation deals with the usage of thermodynamics extension and KPI calculation. Operators and process engineers monitor the status of the plant by looking at measured data via trends and displays. But often there is the need to monitor the process information that cannot be natively seen by measured data and cannot be directly measured by instruments, such as the efficiency of a process or the energy of a stream. So the thermodynamic extension can provide you such data and calculates the equation of states of the multi-component mixtures. There is a data bank for chemical species, many chemical species, more than 250. And for those of you that are interested in applying thermodynamics in a refinery, there is the petroleum pseudo component also. Of course, the thermodynamic extension is natively integrated in the asset framework, so it can be used as a simple data reference if you want. And it executes calculation for several physical properties of the streams, such as the enthalpy, the entropy, the specific heat and density. For those of you that already have Pi, the Sigmafine app makes available the same thermodynamics calculation also for the Pi system. The difference is that here we switch context from case to start time and end time. So you can get the result of thermodynamic calculation almost real time. This is interesting because if you already have a set of Pi analytics in your Pi asset framework, then you can empower with this calculation. For example, if you want to calculate the compressor of the work of a compressor or the power of turbine for a turbo gas, then this is feasible with the thermodynamic extension. And if you have this kind of data, then you can also calculate and estimate the efficiency of your equipment. And it is possible also to write this data to Pi points, to Pi server, so that this data is available to all the users and the operators that have access to the Pi server. The way how the thermodynamic extension calculates the property of the flows is very easy. So it at first defines the composition of the mixture, then define the condition of the stream, the pressure and temperature and the phase. And finally, it calculates the property which you are interested in, such as the enthalpy of the mixture. This is an example of how Sigmafine thermodynamic extension is applied to a multi-stage gas compressor model. The model contains the detail of all the stages of the compressor and considers the intra-stage water injection. The output of this model is that per each of these flows represented here in the model, you have the reconciled mass and the reconciled energy content. So that you can also calculate the equipment parameters and KPI which you are interested in, such as here we have an example of a compressor, and we can calculate the efficiency of this compressor. But what about the accuracy of the KPI that you can calculate? Of course, the accuracy of the KPI increases if we consider a validated data provided by the reconciliation analysis instead of the raw data coming from your plant. This is a case of Sigmafine mass and energy balance applied to a steam purification column. The reconciled specific consumption of vapor at the reboiler of the column at the end was bigger than the measured, resulting in almost 2,000 euros per day of hidden operating cost. This means that thanks to the reconciliation, the users can understand and have a better insight of a better knowledge of the plant. Also, the uncertainty around the reconciled data is smaller respect to the uncertainty around the measured data. And the operators can compare the two information between the steam consumption, so the energy consumption, and the quality of the product, and can choose the best compromise between reducing the energy consumption and producing the best quality of the product, still maintaining the product in specifics. We already said that today the energy management is more important than ever, and the cost of using energy has risen exponentially and will continue to do so. The standard 50001 supports the organization to use energy more efficiently, creating an effective energy management program. As for the other standards, it consists conceptually in 4 stages: plan, do, check, and act. So the amount of data to handle is very huge. And the key for an effective energy management is take decision based on good quality information. Of course, if the data that you are managing had a very bad quality, then the result is that also the energy management program will be also bad consequently. So to support the energy manager activities, Sigmafine can perform a model-based process monitoring. Here we have an example of a model of an industrial furnace where an integrated mass and energy balance is executed automatically every 12 minutes. So the output of this model is very similar to the one that we saw before with the compressor. Per each flow represented here, we will have the reconciled mass and the reconciled energy content, so that it is feasible for the energy manager to understand and calculate the properties of the equipment which is interested in. For example, the efficiency of the furnace that here is represented. Another benefit is that Sigmafine can also provide you the quantity of unmeasured flow, such as the air that goes into the furnace. The energy manager can also be interested in calculating the reconciled oxygen content in the flue gas, which is an important parameter to understand if the furnace is behaving in a good way or not. The Sigmafine results can be automatically aggregated in a dashboard to improve the real-time operations in the control room. Here are an example where Power BI was used to easily monitor your data and to detect unexpected behavior of the plant and take corrective actions. Data are accessible online and by mobile, so it is very easy to monitor the plant even if you are not in office or from outside. And you can also recognize the achievement of your corrective action, if you are behaving good or not. This is an outcome from the model that we saw before of the furnace, where it is very clear how the KPI accuracy increases if we consider the reconciled data instead of the measured data. If we calculate the efficiency of the furnace, considering the oxygen content measured from your plant in the flue gas, then we cannot recognize any correlation. So this is the example on the left part of the slide. On the contrary, if we calculate the efficiency of the furnace considering the reconciled data, the reconciled oxygen in the flue gas, then we can see how the efficiency is correlated with the oxygen content, reflecting the real behavior of the furnaces. There is also the possibility to correlate the crude batch, so the energy manager can have a knowledge of which is the behavior of a specific crude batch, also in order to plan for the planning activity. We saw how Sigmafine can be applied to the energy context for any industries. We saw application in LNG, power generation, utility networks of big plants. We also saw how the KPIs calculated on reconciled data are more accurate and can help the operators and the process engineers to improve the decision that they can take. And we also saw how Sigmafine can support the standard for the energy efficiency. So this was the presentation. I hope you better understand how Sigmafine can be used beyond the production accounting and the material balance.
We would like to thank Eleanor for presenting today and to each and every one of you for attending. If you have any further questions that come up, please feel free to reach out to us, and we look forward to continue the conversation.